So I see that most of the meetups don't start on time, but thank you for being on time. And welcome to today's meetup on microservices and Docker. So we provide solutions to our customers and users, right? So in order to do that, we build applications. So in the past, we build our application as a giant one, which is a monolithic one, and we host it on our premise or in the data center. But things have changed recently, not recently, actually in the past. So now the industry is moving towards cloud computing, right? So imagine G Suite, Google products are developed as a one huge giant application. Imagine the pain you have to go through if you want to scale the Gmail for 1.2 billion users current state, right? So when you are building application to support cloud, it should be super fast. It should start up fast, serve fast, and when it's done, terminate soon. So to educate us on these theories and technologies, we have three speakers today. Leonard, he's one of the main architects at Spios Belgium, which produce and manage administration of e-documents, archiving, and e-invoicing solutions to their customers. After a few years at Solver Research Center as an automation engineer in the automotive industry, he joined Spios as an enterprise domain architect. He's responsible for architecturing the web solutions for document administration and routing using different Java technologies. And we also have Sudarshan working as an associate tech lead at content management and solutions with over 6 years experience in Java development, covering multiple frameworks. He's passionate about keeping top of new technologies with his development, with the industry research and new conventions and technologies. And finally, we have Remy, who is the ICT Solutions Delivery Engineer at Spios Brussels. He's in charge of setting up new tools such as monitoring platform, continuous integration, and he's passionate about IT, programming, in particular project management. Also, he enjoys automating repetitive tasks in his leisure time to make the human life more easy. Right, welcome you, and I will hand over the.
So, good evening. Here we are to look a little bit around Docker, especially. Okay, is it fine? Mic is fine? Can't hear? Hello? Is it okay? Okay. Can I increase the volume? Yeah, it should be now. Yes. Spios Vipost here from Sri Lanka, and especially working with Java technologies. And recently, at least 6 months or 8 months before, we started working with Docker, and we found it really interesting and really fun. And we thought sharing our experience with you and see how it's going to work. Okay, let's dive into the presentations and the talk. So yeah, it's Docker and microservice. Okay, so let's start the Docker explanation in the classic format. You know, everyone compare containers with virtual machines. So let me also compare. Techniques is useful to resource isolation and allocation. You know, both of these techniques are to have isolated environment to run our application in a environment. I mean, if ever we want to have Ubuntu to run some application, if you want to have Windows, and furthermore, let's say we have Ubuntu and we have Ruby on Rails like version 2 and we have version 1. And if you want to maintain multiple application, so it is difficult to handle all at the single environment. So we like to have some sort of isolation. So these two technologies are helping us from beginning with isolation, and containers are also not very new technology. It is they are from very old days. Yes, so both of them works with virtualization. It's fine. And one of the candidates for virtual machine is VirtualBox, and with Vagrant we can automate or script this kind of a tool. For container, as we are interested in speaking about Docker, so we take Docker as our container example. And here in the virtual machine, the isolation at hardware level, I mean emulation, you have like hardware isolation when you, if you see when you install a virtual box and if you create a virtual PC, it's kind of isolation that you're creating in your environment. So it is so much of a hardware level. This is so much of a OS level. So if I am showing here, you can see two pictures. That is on infrastructure, on the virtual machine side. In the infrastructure, you see some guest OS, right? So those are very full stack OS that is individually in virtual machine. But if you see the other image, there is only one host OS, only one operating system, and multiple containers are running on top of Docker machine. So it is kind of basically it's work on a Linux kernel, a very lightweight Linux kernel. So is providing the isolation in the Docker environment in such way. Okay. So yeah, okay. I already explained it's a own copy of OS. Each virtual machine has a own copy of OS, and it shares the OS kernel. And again, virtual machine is so big, anyway, if you are having a CentOS image, it's at least 700 MB, 600 MB. And to be honest, the smallest container is Alpine. Smallest container is Alpine, and I think it is 6 MB, right?
Yes, Alpine is 6 MB.
Yeah, Alpine is just 6 MB, so it's kind of a very nice, you can have a very lightweight OS starting from 6 MB to start prototyping, doing your POC. If someone asks, is your application is compatible with Angular 6, you simply just, you can add some bundles and check it. You no need to uninstall all Angular and break the working modules in the host machine. Okay, and then so virtual machine, you can it's each considered as an individual machine, so you can have multiple containers. I think at least you can have thousands and thousands of containers running in one machine. So let me start with the Docker file. So Docker file is the starting for the Docker. Here Docker is a text file, where you it is the manifest of it, the container. So you will define the Docker related manifest in that file. So you will use Dockerfile to create your own custom Docker image. Yes, you are creating your image from the Dockerfile. Usually Dockerfile starts with the base OS. Yes, as we know, to start any container, the base OS is must. The smallest become the Alpine. So base OS, it starts with the keyword from. Then step by step with multiple layer, we create our required image through multiple run command. Yes. Through multiple run command we do it by installing various bundles. Then finally we define the entry point, which is to be executed at container starting. Okay, let me ask a few small things. All of your what's your experience with Docker? Have you already started using or new? Can I just ask to raise a hand who have not used Docker so far? Okay. Using in the company for some time and already having some experience with Docker? Okay, nice. Okay. So we'll have to manage this talk catering both the people. So just whoever knows Docker, you will see. Okay, we are just discussing some basic syntax, but we need to discover that as well. So this is a very basic Docker file. So I will just take this. Okay. This is very basic Docker file. As I mentioned, it starts with the from. So here you will be mentioning a base image. So here you see logstash. It has nothing to do with any operating system or operating system reference. Here the thing is that there is a registry called Docker Hub, where people can build their images and push those images to the registry. And it is more like you define your Java classes, you extend from one and one. So the topmost one will be anyway operating system specification. So Logstash have as is operating system in the top layer. So here you will not say operating system related any naming here, but still it does share operating system. So as I mentioned, here I will just say this add is a keyword. When Docker file is built as an image, you make each instruction what should be the behavior of the image and what are the things to be included in the image. So to do those, there are few commands. So few commands here, add, and we can use of course run, and there is a command missing, of course copy. Yes, with those command you can copy content to your image. So let me just try to so we are in the root of this file, right? So I should point the finger here. So here, this is the file, and we are in this root. So we are going to run our first Docker command. So we are going to build the Docker image. So as you see, now what it has done. So it just downloaded the base image the base image, and it creates another. Here you can see there are 5 steps, and each step is considered as cache, so layer. So each layer is cached. The advantage is, when you build your image multiple times, if there is no change in one line, it's not going to build it again. So that's really advantage when you build a very bulky image. It does not create from every time, it caches. So more you use, there are 2 perceptions. People say you can run every command in single line with and concatenate it. So it will make a single cache, and it will rebuild each time. That's fine, and it's easy. There will be only one cache, and it takes less memory. Yeah, there are a lot of things we can discuss on that. And I see special advantage writing into multiple layers, right? If ever there is a change, only that layer get built. Then that makes really, when you are just multiple time building images, it saves you a lot of time. And yes, so as I mentioned, see, add is a keyword in Docker, so there is a layer created there. So so this is our first Docker command. So we just build the image, and we can see the built image. Okay, I'm not sure how to show it in a better way. Sorry? Okay, it's fine. Alright. So you can see the newly built image app, and that size is only 183 MB. So it's going to run a Java application. How wonderful it is with the 183 MB, you can simply have a running environment to run your Spring Boot application. So let's say if you have a application that runs on Wi-Fi, it's going to be another 15 or 20 MB. With 200 MB, you can have an image. And then the good thing is you can have multiple versions of Java versions, encapsulated image containers can be run in the same environment. That's the real advantage with Docker. So we are just copying the file, and okay, that's it. So there are so rest of the command is very self-explaining. You can understand with what is add, what is expose, and working director. Those things are very self-explaining. I want to take a moment to explain. There is this special command, which is a bit confusing between developers, right? So run is, you can use multiple CMD command. That means you can have multiple CMD, but multiple run command. But basically you can have only one CMD and one entry point, because even if you have multiple CMD, it is no point. It does not make any sense, in the context of development. So. So that's it. I want to mention that, but still all of them are going to do the same thing. Run is just going to execute a command, and CMD is also going to execute a command, and entry point is also going to execute a command. So if you see, there is an entry point. So this is the entry point for this container. So when you are running this container, this application will run. I will simply show this here. I say Docker. And I say it is interactive and app. Okay, so Okay. Do you read the font? Is it already fine? The sizes from back? Can't see. Okay. 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 You'll have to manage. Okay. So here you can see, this the Spring Boot log that you're seeing here. So this is the entry point where the container is set to. So when you are running your container, when you enter the bash, you simply see the logs of the application. So that is the entry point basically. And I want to show this. So I started the container in interactive mode and my cursor is blinking here. So if ever I'm pressing Ctrl C, I exit the container. So there is another command. I can see the running Docker container, so I don't see container. So what's the use? You just run the container, and if you press Ctrl C and it exits. So if you want to keep the container live, you try to run it in detached mode. Okay. So now you are no more in the log output. Now you are in the container. Container. Then if ever you say list your containers, you can see that container. And let's say now you want to log into the container and see something what's happening. So there is a command called execute -it nic. I did not specify a container name, so that Docker just create its own name here. Better to copy the ID here. So I can say. I can work with the command like this ls. The command I want to issue on the bash of the container, so it just issued me the ls. So if ever I'm like let's say I'm on the bash, so I think this is sh and I say list. It's not my host machine. I'm within the container, and you can see a whole lot of Linux file system there. So it's basically an operating system that you can work. So basically, if you want to install some tools more on here, you can install, and this container you can make it as you want. Okay. So does it look different than virtual machine? Because you create operating system. You log in there, you copy your application, you install your software. So it's very same to the virtual machine, but it takes very less space and very convenient. Okay, that's all. So I exited and I'm on the host machine. So that's it. I just want to say what is Docker. What is the advantage of the Docker? These are the principle I just want to show a little bit attention. It is portable, the density, the scalability, the integration and isolation. Portability is, of course, this is the classic statement that everybody say when somebody asks what is Docker. Somebody say it works in my environment. It's not working in my environment. It's working on test and not on prod, on dev, and it's so. That's a classic statement. They try to solve it with the Docker because if ever it's working in somewhere, it will work in other place. Because if you, as you remember in the first slide I showed, it will bundle all the library and the application in it. So it doesn't depend on external resources except the operating system kernel, that Linux kernel. Okay, so that is portability. Maybe this is right. Your application is there, you can simply carry and leave it somewhere. Don't want to worry what sort of environment it is, and it is fully protected with this container. So it's of abstraction in the infrastructure. You don't want to bother about is it Linux or Windows or anything. It is abstract. Mostly it should give you the freedom in hosting solution also. So let's say your AWS is so costly, you want to change to some other hosting solution, you can simply switch You have nothing to do. You install the Docker, copy the Docker files, and just run the Docker files. That's it. And multi-platform support. Yeah, that's it. So it's self-sufficient container. That's the cool thing. You don't want to install the libraries separately. So as I saw the other application, just it is 180 MB, and it is not only the application but the environment also. So you just send to some someone else in some other machine. It need not to install Java. You have it will be running out of box. So density and scaling. So this is the one. When you have a virtual box, there are a lot of limitation. You can have a hypervisor and increase the capacity, but still there are limitations. But when it comes to Docker, like let's say the same image I'm going to run 100 times, 100 container. It will not even create 100 times 180 MB. It will be only 180 MB, and on top of each running container there will be a thin writable layer. I will try to show you later in the slides. It means that each image, even if you run 100 instance, it is not like 100 times 180 MB. It is only 180 MB, and rest is small space taken on the writable layer, maybe for the logs or for some processing. That's it, right? So here and there, if someone has question, you can raise a hand and ask, how it's going to work, and if you want more explanation, something, you can raise the hand and ask. So I'm just diving to image. Images are made by a series of layers. Yeah. As you see, there are 5 layers. So one image made out of 5 layers. Basically, each layer is also image. If you say the history, each layer is also image. Normally, images are archived and managed on the Docker registry. Yes, the public Docker Hub is the one where people share the public and reusable images. Let's say you have Alpine and you install Nginx on that, and if it is working very well, you make it little clean and you publish it on Docker Hub. Then next person can use it. Okay, so this is very similar to Maven, right? I think you are familiar with Maven, right? Most of you are guys. So in the Maven, when you are just building your project, if you say mvn clean install, it'll just create the jar file and place that jar file into your M2 directory in your local machine, and you can still publish that jar as one of the dependency to the central Maven repository. So whenever you are requesting from another application, let's say I need a util jar, you say the POM description, so it will first look into the local registry, and if it is not found, it is going to look into the public registry. So it is same here with Docker. Docker has the local caching and registry. So whenever you ask for some images and cache, it first look for the local machine, and if it is not found, it is going to the remote machine. So some organization to reduce the bandwidth with the internet and stuff, or maybe to have more secure, we can even configure a local Docker registry private to our company, right? Maybe like rest of the speakers will cover a little bit on that, and it is more. You have points, right? Okay. So that's it. So you can manage well, and these images can be reused, and that's what I want to tell. Okay. So images are also stored in local registry for fast access. That's that. Image can be versionized with time. Yes, that's the other advantage, right? Let's say you want image Java with 8 and Java server and 5. You can tag it. Basically with Git, you tag your versions and branch it. So a lot of inspirations are coming from Maven, Git, Linux. So Docker is all about this. It got inspired from them, and basically even this container is not very new. From the even you can write a C group namespace. They are in the Linux environment without Docker. Also, you can just start a process which will have entire file system in it. So there are some things we can work around. So containers become the last and the writable thing layer. Yes. So containers are created from the image. So as you see, I created a Docker file, and from the Docker file I built the image, and from the image I ran a container. Okay. So container running instance of image, multiple containers can be created at the same image. Yes, I can have like app1, app2, app3, multiple instance of image containers. And each container has its own writable layer. Yes. So even though you create multiple containers from the same image, they are going to have each its own state. That's the thing. You don't want to think like if you create multiple container from the same image, they are going to be same, but they can be having their each own state. It's like more like a Java class. You create objects. Let's say you have a student class, and you create student A, student B, student C. So student A can have its own status, and student B can have its own status, like that. So this is a very good image. I'm not sure all of you seeing this. This is what I want to say, right? Maybe I will try to. Sorry, I will try to show it here. Is visible? Fine. Okay. So if you see, there are 4 layers, right? Each layer has its memory thing, and this will be the containers, right? So this is image, and these are containers. So you can create any number of containers from the same image, and they will be different. So okay, thing is that maybe now let me I will just show, I'm just trying to sorry, it's not like this. Yes. I'm just creating another image. So it shouldn't be in interactive mode, it is in the detached mode. So okay, so you see okay, so you can see these 2 images created here. So let me try to say now I'm trying to connect to one image. So now I'm in one container. Sorry, I won't be able to show that because here I don't have in command. I know I do. So if I say I have config, So I do have a IP address, right? So each container will have an IP address, and if ever I'm going to communicate with another container, I will have to reach through this IP address. So it becomes very difficult to manage in many environments. And there is another solution in Docker that is called Docker Compose. What it will do, it will list all your containers, record containers as service, and it will define a network. So I will try to show. This is a Docker Compose file. This is one of the Docker Compose file. So here you can see. Yes. Let me start. So you can see this is Elasticsearch, right? Elasticsearch is one of the one from a public Docker hub, right? And I'm just giving a container name, because you notice when I am running a Docker container from an image, I did not specify a name. Even there I can specify a name, so I don't want to spend much time there, so I came here. So here you can specify a container name. And this is port, where you are exposing your service to the host machine. And then this is network. Here I'm just trying to create a network in a bridge type called backend. So this is one service, right? One service. So here there is another service. Here you can see slightly different. Here there's a build command. So here I'm just trying to use one of my local image. This is like from public registry. This is from my local registry, right? So here this is my folder where my build Docker file is there, and this is the image file I want to build from that Docker file. So here again I'm creating this backend, and I want to take little bit time to explain what is this volume later. Yes, let us see. I will try to. So earlier we were using all Docker, so now we are still going to use Docker Compose. So as you saw, there are two type of services I showed. One is we are just using one of the local image, and if you are sure it is very up to date, we don't want to build again. And if we do any change, we need to build that. And when we say I had two local images which I want to build, I just want to build and show it. So I want to build it, I built it, and then what I do, I say, now let's say, before that I will just check Docker. Yes, sorry. Just trying to clear all the local containers just to have a clear view. Okay, see, it just cleared. Let me remove. Yes, there are special things you will learn while you are practicing it. when you stop the container, it is stopped but still alive. You need to remove for you to free up really the space. So I'm trying to remove it and clear it. Yes, now it is clean. Yes, it's now clean. So I am in here, and I say up. So it's just creating the services I wanted. Let me now see how many containers. Yes. Now you can see, yes, 1, 2, 3, 4 containers are here. And now you also can see that, there is expose, whenever there's some service are running in the container, it cannot be accessed in the host machine without exposing it over a port. It is isolated, as I mentioned, it's isolated. So from the host machine, you cannot go into use one of the service or some service in the container without exposing. So I'm just exposing it for my usage. And here, of course, you don't want to expose this port, but still, for demo purposes, I'm exposing it, right? Yes. I will try to take this one. So this is a very small Spring Boot application. I just defined as an API where it will retrieve the set of users. So here, you saw I did not do much configuration. I was just using Logstash, Kibana, and Elasticsearch, right? So you could see that. Number 5601. See, it created my Kibana, right? So here I can, anyone familiar with Kibana, Logstash, and Elasticsearch? Yes. Especially when you have to do this, you want to spend a lot of time in configuration, and it's very difficult to, sometimes it goes wrong. Here, I did nothing, just I specified some public images from the Docker registry, and I'm using it. So here, yes, you can see this. There is a little bit different in the time zone. No, it's good already. It's 1960. Yes, yeah, it's perfect. So you can see this one. I will just issue one more call here. See, you can see the 4th hit here, and you can see the log. And it is very useful. In this point, I just want to explain to you, this is a very useful tool for monitoring, because especially when we are, when our infrastructure is getting so complex, it is must to monitor what's going on and which nodes are active and what sort of traffic is working. So this is a very good tool. Maybe you can have a time to search it, and here you can see the request, and just see it in the time frame. It's a very nice tool. You can use it to the Kibana. So, okay, so what I want to say about microservice from monolithical system is it is just two pizza team. What it mean by two pizza team? It's like it's very small. The point is not making small, but making the communication so efficient, between the people. That's why you normally say it's two pizza team. You should be able to feed your team with two pizza. So, but someone is so hungry they will eat so much of pizza. So that's it. And microservice is componentized in the business capacity. It is not like one big application will have user module, account module, and every module, but it is componentized on business capabilities and scale. Here, in monolithic system, if you want to increase the node, it's very costly. You need to spend, RAM is very costly, and processing is very costly in the cloud, so it's difficult. But in microservice, it is very fast for you to scale it, and CDCI is very friendly. It's a continuous delivery and continuous integration with Jenkins. You can have, when you are starting practicing Docker, you will have a lot of questions. Someone will say you can embed the application within the container image, or someone will say you can externalize the application. But if you are embedding it within the application, you can just imagine how many images going to be there. So it will be very difficult for you to manage. So CDCI is very important when you are practicing your Docker in your company. If you start practicing in your development, CDCI becomes very important to automate some stuff of deploying. When you do a change to the Docker file, it just should update the registry. That's it. So again, microservices are very easy to upgrade. Yes, because if you are working with the user module, let's say you are using some Java on Wi-Fi, and you think you want to migrate to Spring Boot, you no need to work in the whole system. You can just take only one component and start migrating, and it will be much easy. And one disadvantage with microservice is complex database solution, because the microservice promote the database to be centralized to each service, but in real world such kind of situations are very less. In a accounting system or in bank system, you cannot have multiple database. It should be one centralized database. In that instance, if we are to give the advantage of scaled application to the user, we need to install more complex database solution like Redis, JMS, kind of asynchronous process, and lot of controlling on the data to manage the efficiency, and at the same time we should guarantee the atomicity also. Yeah. So that's about microservice. So okay, so that's all about. I want to talk about Docker. So here. We started knowing what is Docker, and we went through few commands, and we just created the Docker images from the Docker file. Then we understand some problems when we create multiple images from the Docker file. It's difficult to build every image and manage the mapping. So the Docker provide the solution as Docker Compose. So then there are a lot of topics are unfolding, scaling, and clustering, those kind of things. So Docker got two version. One is Community Edition and one is Enterprise Edition. So we are lucky to have orchestration in the part of the Community Edition. So I'm just going to hand over the talk to Remy. He will start explaining what is Docker orchestration and scaling and clustering.
guys. Hope you are enjoying the session. So just to spice up the things, Remy will ask you question. So the first person who will ask the question will get a small gift. So Remy, it's up to you.
Okay, so what is Docker? What is Docker? Maybe that is a too much large question, but if someone can tell me what is a layer in Docker? Okay. Okay.
So each and every instruction in the Docker file, it will create a layer.
Yeah, right. You're correct. It deserves it. So maybe I will ask last question. Yes. So how can I list every Docker images I have on my computer?
PS.
Sorry, PS? PS will describe your instance of images, but not your image. Yes, you're right. So you won. Yes. Okay, so maybe I will do another question.
No question at the end of your session.
Yes. Okay. 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 So. Just wait, and I will try to do my best to zoom in. Okay, so it seems fine. Hello everyone. So I will present myself. It's a big one, button. Okay, so sorry for my bad English. I'm French, and you know French are the worst. So please don't be. Okay, so I'm Remy Matteo. I work as a Spios solution delivery engineer in Belgium. I'm managing some Docker at my work. I'm prototyping some infrastructure. I also work with Jenkins. Someone know what is Jenkins? Okay, so Jenkins basically is some bot that is born to do some automations, such as building Maven and so on. Because you know, I feel a little bit tired to write Maven clean install every day. So I also work with Elasticsearch, Kibana, and Logstash because monitoring is really important. If someone are really familiar with it, I'm also working with ElasAlert and Curator, which are some famous products about Elasticsearch team, and that's it. So I will start the Docker tools by talking about Docker Swarm. So Docker Swarm, I hope everyone understands Docker now. You are Docker expert, so we'll switch to the next level, right? Okay, so Docker Swarm is just basically an orchestrator. So it will be on top of the Docker. You know, it will manage Docker, it will manage a cluster or something. So it is just a new tool to organize the Docker engine. So why this are born? I think you know, you have, for example, two servers. Okay, you want to run two Docker, but you want they talk with each other. That is really difficult. You have to open some port and so on. And if you want to deploy it at the same time, that is really complicated. That is why Docker Swarm will be here. Okay, so a cluster basically a set of nodes. So node basically is a machine, or a virtual machine as you want, of course. So you will use Docker services. So as Docker Compose is described by Siddharthan, JK. And that is the same syntax to write a Docker Swarm stack. You have some small difference. I will switch to them soon. So why Docker Swarm is a little bit famous, if I can say, because it provides clusterized services. It provides high availability about if, for example, you have a multi-node, you have 5 nodes, okay? If one of the nodes fail or burn or you crash it, I don't know, then your design will be still responsive. You will still have 100% of response, so it's fine. And also, what I really like Docker Swarm, it provides horizontal scalability. So basically, instead of buying a big server with I don't know a lot of RAM and a lot of CPU, big one, you can buy a small server and make a cluster with them. That is very cheap, so that is nice. For example, you can do it with Raspberry Pi, which are not that expensive, and you can make a cluster of Swarm with it. For that, please use Hypriot OS, which is a good OS for doing Docker in Raspberry Pi. Okay, so do not hesitate to interrupt me if you have some questions, because I may be answering if I can. Okay, so we will talk about cluster management feature. So you have two types of node in Docker. So one is worker, so basically it's just a worker as we said, and manager manage worker and also can run Docker container. But manager are really important. Why? Because if you lose too much manager, the cluster will fall, and the entire stack will fall as well. So you have to take care about it and be put the Docker manager on the best node you have. So basically, if one of manager fail, there will be safe electing people, electing server, I mean, to elect a new manager, and like that you will be able to stay alive with your Docker cluster and your engine and the whole entire stack application you have. So it's pretty nice. Also, you have some network management feature come with Swarm. It's load balancing, internal node routing, discovery service, and abstract exposure about that. So basically, I will take a small example. For example, you have a free application Spring Boot, okay, and you have one Nginx. So you will try to make some road between them some way, and with Docker Swarm you will be able to have to scale them to 6, to 9, to 90, to whatever you want, whatever you can also. But it's pretty strong feature. So I will talk about internal routing feature. So as I said before, you have some Nginx which will talk to service one. So basically you have two my services. So how can I know which one I will hit? They have the same DNS name, and in fact the engine DNS server will do the load balancing for you. They will say, okay, this is this one this time, and this time this will be the other one. So you will have some load balancing between your Spring Boot applications. So you will be able to not overload them. So it will be nice. Any question? Okay. So now we will talk about abstract exposure. So this is the strategy of Docker. For example, you have 3 manager nodes. Everyone is hosting one Docker with a website. So normally, in real life without Docker, you have to to do the curl on your navigator with the right IP address of your machine, which are hosting Nginx. On this kind of type, you will be able to run on any of manager node, because Docker will do the routing for you, so it will be nice. Very powerful feature. So now let's talk about a workshop. If you have a computer, you can do it as well. It depends. It depends. So we will do a simple Docker coins mining. So so there will be some 5 applications. So basically, everyone is described, but maybe I can try. Everyone can read or not? Comme ça? AK? Okay. So you have one on top, which is energy. So it will basically just random a number generator. So you will just reply 5, 6, 7, whatever you want, in randomly, of course. And you have the worker, which will scale with energy agent, and he will push the random byte to the HR, and the HR will hash. Then he will push to Reddit, then you will see into the web UI, okay? So basically, web UI will be JavaScript frontend, and Azure will be some little applications. So it's a very common case, because you can compare it to your Stack application. You will have one Spring Boot, you will have one database, and you know, database is always a problem. So let's continue to this. We will deploy the service as a stack, integrate 2 nodes in the cluster, and scale it to 5 agents. So if you are ready, it will be demo time. I hope everything will work, but you know, in those cases, nothing works. Okay, so there is the address of GitHub if you want to do it with me or to do it later. I think we will start do it. So for now, I prepare normally 2 VM, which are here. I don't know if oh, it is a little bit too big, I think. Okay, so there is some comment. Okay. Yes, that is way better than this. I don't know why, but okay. Okay, now you should see everything. Is it bigger enough? I hope yes. Okay. Well, you can move on now if you want, no problem. Here it's my my node. So I don't run any Docker. So let's start do some swarming, guys. So it's basically swarming it. Oh, I'm not on the golden node because I did something wrong. So there will be some problem. That will not work, I think. Okay, because I have multiple IPv6 in my MAC address, so that would be very hard. Okay, so we will talk about that, and I will try to repair it for later. Sorry guys, it happens. I should not put in the play mode. So you have some additional tune-ups that you can put in your Docker Compose. So basically you can say a lot on your deployment strategy. For example, you can say, okay, I will deploy this application only on Ubuntu, or only on CentOS, or only on Windows. Whatever you want, you can target one OS using operating system. That feature is really nice. And also you can limit also the power of your container, because otherwise it will consume everything. So you can say you will have a small memory, for example, 50 megabyte and so on. So now I will be catch up later for Docker Swarm, and I hope it will work. So let's talk about Docker Enterprise. So Docker Enterprise is not free. Docker Community is free. So that is the main difference. And Docker Enterprise provides some good tools. For example, they provide UCP. What is UCP? It's an interface management for to manage Docker clusters, stacks, services. They also manage Kubernetes. So Kubernetes is an orchestrator from Google to manage Docker. So that is quite nice. And they also provide monitoring out of the box, which is really fine. For those who don't want to use Docker Enterprise and still want to monitor their container, I think you can take a look at MetricBit, which is a product of Elasticsearch, and you have some Docker module, and you will be able to monitor your Docker container like this. Okay, small parenthesis. Okay, so that requires many nodes, and you will have a license for that, but you can still try for free. It's 1 month free. So if you want to try, just try, but take your time because it's pretty big. It can represent a very big investment for your company. So it depends on the size of your company, the size of your work, the management, money, everything. But we will describe a little bit more the UCP. Okay, so there is a screen for UCP. I hope you can see everything, but I think not. So I will try to describe as much as I can. So you can see some monitoring. So you can see how your node is right there. You have some code related to CPU, memory, and disk usage. I think those three information are cool because of that. You can see some Kubernetes informations about your pods. So, or about about your pods. And you also have some Swarm informations. And if you can see at the navbar here, you can have some dashboard management. You can see some shared resources, such as, for example, Docker Volume. So what is Docker Volume? Docker Volume is a storage managed by Docker, which can be shared between Docker or between your host. So that is pretty much easy because, for example, if you have your configuration file into the volume, you can change it from your host and then restart your Docker and so on. That can be good. So I will switch to the next one. So the next one, it's pretty interesting because it will describe your team. So why this is good? So because you can create multiple teams and you can create a good access. For example, they will say, okay, integration team cannot develop on the project of the developer, which is nice. And you can always do some access role and privilege and so on. That is quite nice, and that is also integrated into the Active Directory. So one thing which can be good in a company, I think. So if you don't have any question about UCP, I will switch to DTR, which is one of the most interesting things in Docker, especially if you are worried about security. So that is why. So as I said, you have the DTR, which is here. So basically, DTR is like a registry, okay? but it's more powerful than that. The DTR can be on your company, hosted in your company or in the cloud, or whatever you want. You can store your image in it and not in the Docker Hub, so no one can access to it. And you can also do the same with the Docker registry, but Docker Trusted Registry is able to recognize if you sign your image, or maybe if it can run some privileged access. For example, developers are able to push the image for Spring Boot, for example. Okay, they will push the image to Spring Boot. Okay, and for example, someone of the DevOps team want to push something on the registry, such as DevOps or such as Spring Boot, for example. They can deny it, so everyone can stay at his place. That is pretty nice, but also for me, which is really interesting, is that feature. It automatically scans images, because containers are like everything. You don't want to leak onto container, so you have to scan them, you have to fix them, you have to promote them. So for example, in Alpine there is no leak of security, but if you run the scan on Ubuntu latest, you will see some leak. That is why this is really important, and you can also write some rules on promotion. For example, you can say, okay, I want this container in production only if there is no critical fault or no critical 0-day issue. That can be good, and you can do it through DTR. So it requires internet access, because he has to update his database about leak. So it's pretty obvious. Web interface, some are maybe a little bit hard to manage, but I think this is a great tool for security. That is why I talk about that. So now let's see some screenshot about Docker Trusted Registry. Just a small question before.
Answer that question. Raise your hand, please. You were the first one.
From Docker Swarm, we can manage the containers, Docker containers.
Can you repeat that?
We can manage the Docker containers.
Oh, that's incomplete. I'm sorry. I think someone else has an answer. Yes.
In using Docker Swarm, we can manage containers when hosted in multiple machines.
That is correct. Yes, you're the winner. Let us start with this presentation. So, I'm Lionel Fallis. I'm Enterprise Domain Architect at Spears. And as you can see, we are not so used yet to talk in a microphone. So, introducing my presentation, I'm going to talk about Docker in the industry. So, what you have to understand is basically we are Docker enthusiasts. It doesn't necessarily make us expert, but we have as much knowledge as we can have based on what we could already experiment with that. So for us, Docker is still an ongoing project, definitely. And we as a team, the three of us, Sudarshan, Remy, and myself, we are currently working as a team and increasing our experience a little bit more every day. So for us, the purpose of this meetup is really to share our experience with us, with you, I mean. And so don't hesitate if you want to discuss a bit more. After it, we can share our experience. If you have some experience that you feel you can share with us, please come and meet with us. So the first question you have to ask when you start doing a bit with Docker technologies is containerizing for you? Is it the right approach for you? So the fact is that containerizing and Docker especially is an exciting technology. That's how Docker became so trendy in the world right now. Everyone wants to try it. Containerizing is not new. It has existed for years and years, but it's becoming more and more available to everyone. So this question you still have to ask yourself: is this technology useful for your company? You as engineers or as architects, you have to wonder before implementing some technology, what will it introduce in your company? What about security? What about dependencies? How to maintain those layers? So there are a few questions you have to ask. So first of all, do you meet the requirement covered by the strength of those technology? At the very beginning of the talk, Sridarshan introduced you a little bit what are the strengths of Docker. So we talked about portability, scalability, those kinds of things. It all sounds very nice, and definitely it is. If this is a requirement for you, this technology makes it way simpler than before, I guess. So to answer those questions, you have to figure out in your context, how is your company application life cycle? Is it very agile? Do you have a lot of software legacy? Because those most recent technology, they require some specific architecture. So Sridarshan talked a bit about microservices. Of course, those technology are closely bound to those architecture design. It's not for every design, I want to say. Also, as any new technologies, it requires some learning curve to go through. You have to train yourself, you have to train your teams, you have to train everyone involved in Docker technology. So that means there is infrastructure requirement that you have to go through. Again, security concerns, so not everyone is an expert on all those domains. That means that every domain needs to be covered from each perspective by the appropriate people. So I'm here tonight to share with you our thought process. So as I said, Docker is still ongoing at our side. And the way we are thinking about it right now is there are many options. Docker is very, very modular, very, very open. You can really approach it the way you want, and it's by design. That's the way they wanted Docker to exist. And one of the first questions we were wondering when we started implementing those technologies is, am I implementing the best practice now? Is it the correct approach? And at the beginning, the only way to figure this out is by questioning yourself, discussing with someone that has some experience with that. And at the beginning, it's not always easy to find. So you start, as Sridarshan said at the beginning, is you will have many questions, definitely. And the fact is that, from my experience at least, I believe there are no right answer, usually. It really depends on what you want to do. What do you want to do? Do you want your container to be fully portable? So you need to make it self-sufficient. So you will have to implement best practices allowing this design. But if what you want is just create an abstraction layer to ensure that you can not be concerned with infrastructure anymore, then maybe what you want is build up some generic container that can integrate easily in all your environment, and you can easily do validation and move to production, figure out which is your life cycle, which release is on which environment, those kind of things. But the fact is, once you decided that you want to go for those technologies, you have few options. And we discussed a bit about those options. There is Docker Community Edition, like Remy mentioned. This is the free approach, and usually that's the way you can evaluate the technology. And Docker also is available as an enterprise edition. So what's mainly the difference between those two editions? actually you can really build up enterprise software using the community edition. Of course, you won't beneficiate from support from Docker editors, teams, but you can still build up your scalable software solution by ensuring you have load balancing through Docker Swarm, for example. That's only one use case, of course. But what Docker Enterprise Edition brings is since very recently, incorporation of Kubernetes natively. So now I want briefly to do a vote and raise your hand. The people who knows what Kubernetes is? Very few of you. So do you know, because you work with, raise your hand if you work with Kubernetes? Okay, very even fewer people. Okay, so basically Kubernetes is kind of concurrent product compared to Docker Swarm. It supports many other technologies, but it's been developed very closely to Docker solution, and it has been developed and maintained by Google from the very beginning. The reason is, of course, Google, as a very big software editor, had the same requirement that we are having on our everyday developer life, and they decided to develop their own solution. In the meantime, other solutions have been developed, and they are a bit conflictual in some ways. So as I said, it's a bit conflictual in some ways. So the approach Docker decided to follow is that in the new release, the new Enterprise Edition, they decided to support them both. So you, as architects or engineers or developers, you have to decide which is the best tool, which is the most appropriate for what you are going to do. Also, what the Enterprise Edition supporting is few user interfaces. Remy briefly described them to you. Those are some pretty useful tools, although, again, depending on your use case, you might find a solution in the community edition. So I won't do any recommendation to you guys. I think you have to figure this out a little bit by yourself. But in my mind, and the way we are approaching designing those solutions is, it's most likely mandatory if you're part of a very big structure, because it's helping you to do very strong segregation and define very clear separation in the definition of the roles, user roles, and responsibility of everyone involved in the software lifecycle. It integrates pretty well with company tools, so if you want to administrate your user, specifying some groups and defining department to which your users belong, defining access control to those dependency, that's probably the tool for you. And also, again, not everyone can be a Docker expert. So if you have many users involved, those tools will provide you with some friendly user interface that may make things easier for everyone. So for us, our choice so far is not necessarily to commit to the Enterprise Edition. I will explain a little bit later why, but basically our feeling is that we expect from Docker to commit to an orchestrator agent, and we feel like if they don't know which of those software to commit with or to support, it's making it a bit harder for us to decide. At the end, we figure, okay, then maybe for me, I can just make use of the community edition and implement my Kubernetes on my own. Okay, so now that I described a little bit how is our thought process working, I want to tell you a little bit about the way we are designing our high availability architecture. So as I just mentioned, we are thinking mostly about Docker Community Edition, and that is because also we don't see a very big added value in what Remy introduced to you as DTR. DTR is Docker Trusted Registry, so that's the tool you can use to dispose of your images, scan them automatically for vulnerability detection, this type of things. Of course, some of those features sounds very cool. To us, it still seems like it needs a bit more maturity. And also, we started working with those technology at a time when this was not necessarily an option. So we already developed some solution for registry. So for us, that would mean going through some migration of our registry, which is again some more investment. So what we want to do with Docker Community Edition is to combine with Kubernetes. Kubernetes, why? Because it can integrate many technologies. For us, it's kind of a fail-safe approach, because if ever for some reason in the future there is very big change in the Docker strategy, or many different reasons that can make you want to change your virtualization stack, and then it's still an option to continue using Kubernetes. Kubernetes, you can run Java application natively. That's not necessarily a problem for us. That's that we feel is the best option. And also, as I said, it seems way robust compared to Docker Swarm in our mind. It has been running for a while. It's supported by many companies, and it's also in production for very well-known website that you guys probably use on your everyday basis. So in our plans for high availability architecture, we believe it is really important when you start working with many abstraction layers like Docker can offer to incorporate as much automation as it can be done. And the reason why is that we already have so many things to think about when we design and when we engineer, when we architecture our solution, then we cannot cover everything perfectly. Sometimes you need to save us some effort to make sure we can focus on what really matters, stability, testing, those kind of things that you are already probably investing a lot. So what we are working on, and I will show you a small example, as Remy mentioned, is Jenkins integration. What we want to do at the end is to provide a very safe automation process to our developers. I will document it a little bit after. So in our case, we already implemented many monitoring and logging solutions also. Those solutions are covered in the Enterprise Edition, so that's also for us one more reason not necessarily to go with the Enterprise Edition. Of course, for you, if you are still looking for those kind of solutions, then maybe the Enterprise Edition is a good thing for you. So this is an example of the continuous integration and delivery that we want to look into. So the idea is, so if you look at this schema here, the way to read and go through this schema, hopefully everyone can see it this time. It goes from the very bottom left up to the higher level and goes down to the right layer. So the idea is that we want our developer to only be concerned about their code. And to do that, the only thing they should have to do once, of course, they've been finishing their coding activities, is just pushing to their source version control. They should really focus on maintaining their branches, making sure that their commit is documented, focusing on the code. The idea is that they don't even have to know anything that's behind that. They can just figure out, okay, now I'm done with this assignment, I'm documenting it, now I want it to be available for validation for my people, so I just want to push it on my version control. In our case, that's going to be Git. And Jenkins should automatically trigger based on your strategy. It can be different depending on the environment or your company strategy, even on your project strategy. But the idea is for development purpose, we need to have very up-to-date environment. So we want, for example, Jenkins to get triggered as soon as a push is committed, as soon as commits are pushed to one specific branch that's available to everyone. So this push will trigger a build of an image. So what's going to happen is really, our Jenkins is going to build a Docker image. It's not only going to build the application, it's going to build a self-sufficient container that can be started on each of our targeted environment. So in our case, we just use 2 example environments, so there is testing and production here. But the idea is basically it will build up the base image in specific version that's going to be tagged. As Remy explained, it's very similar to code lifecycle management, so I'm not going to go into much detail regarding the versioning. But what it will do, it will also build your image and tag it as a development version of your application. So you can, at that time, do the validation you want regarding your current development, and some other trigger will, some other event will trigger new build of the test version of this image that can be deployed to testing environment and production environment. So of course for us the idea is that we want to have very clear segregation between roles of everyone and between triggers that will ensure each environment are properly updated. As an example, testing environment could be updated once a week or twice a week or once a day if you figure that's what works for you. Production may require extra validation from someone pressing a button if that's even a requirement. And of course, at any time in this life cycle, you could get some help from code reviewers, or everything becomes possible. What we want to provide to our developers, because that's the people we want to help delivering the best quality software, are some tools to help them figure out how good is their development. So what's missing here in my slide is you can have some extra software. Everything that can get integrated into Jenkins can be run depending on the life cycle of your software. As an example, you could run some SonarQube. Hopefully some of you are familiar with SonarQube. Again, please raise your hand if you know what SonarQube is. Okay, only 3 people. Okay. So SonarQube is a code analysis tool, and you can run it automatically in your Jenkins pipeline. So the idea is that any developer at any time can go and consult a reporting of the current situation of their code, and it will help them figure out what's important in delivering the code, like how much test coverage you have in your code, what is suspected to be bug or critical issue, and also repetition in your code, for example. So that's only one aspect. You can also cover with some additional security scanning software. So, and again, this is only I'm guessing the beginning, right? So with automation, I'm guessing we can do much more. So of course, like every technology, when you start putting this into place, you will run into some technical constraints. So I'm asking you to share my struggle here. Actually, I can only talk about few ones that are a bit similar, but they are not small ones. When you start building up your images and your application, sometimes you find yourself in environment where you cannot do everything. Of course, there are some limitations. You can find yourself in some production environment. You don't have every necessary access or every access to every dependencies, these kind of things. It requires from you to maintain dependency repositories sometimes locally. At least it was the case for us. So most recently, our technology stack relies onto Angular, JavaScript frameworks. Of course, Maven for Java application. And every build image that we run, at least in development environment so far, still relies on the CentOS-based image. So for this, it's necessary for us to maintain our own company repository. That can seem easy, but in fact it may be a bit more difficult than it looks like. Of course, but in a way it will enforce you to put in place the best practices regarding your dependency. As an example, if you are running CentOS or Ubuntu images and you want to make sure your software is always up to date, you will have to do some validation regarding dependency. It will force you to get your dependency up to date and not run into such a large technological debt all the time. And it will force you also to put in place a process that makes sure that those dependencies are up to date. So not only will you be validating your software, you will also make sure that every dependency you're using are safe. So now that you guys are all convinced that Docker is the best solution for you, I'm guessing, what are the next steps? So the fact is that you are probably not the decider, and it makes sense. It's company decision. So the people, they will want to know, okay, but what does it bring to me? Yeah, you will produce nice quality software, but what I am having now is already good quality software, right? Okay, that may be true. That's correct. And as always, we are supposed to provide some numbers. I think that's also making sense. And 3 words are usually very good to use when you're discussing with the people that are going to pay the bill at the end is return on investment. So what will it bring to you? And to do this, Docker is offering to you a tool that helping you to specify, first of all, if this is proper approach for you. So it will ask you some question like how many hardware or virtual hardware are you maintaining? How many software are you keeping maintained? How many times do you release them? Do you have many release? And based on this, they will do simulation, and at the end, it will come up with some nice number that you can provide. So as an example here, I included a screenshot of their website, and I will share the link with you afterwards. But using only the default values, it's suggesting that you can save up to about $500,000 in 3 years. So maybe that's optimistic. Then in our case, we'll have to see times will tell, right? Okay. Okay, so for those of you who are interested to review this presentation later, here are the source and reference that we are using through the presentation. Feel free to scan the QR code if you want, and it will link you to the presentation. Feel free if you want to comment there, and if you want to reach out to us with suggestion or question. Of course, on those presentations you will find the sources that we use. So you can find here is a reference to the Docker official website that describes the best practices for the Enterprise Edition. You will also find documentation regarding specification of a Jenkins pipeline using Docker. And at the end, the ROI calculator, which is the one I use at the very last slide to show you a return of investment calculation. Time for question. Please raise your hand if you have any question for me. No question? Everyone's hungry? Oh, you have a question? Go ahead.
So I think Remy, you can answer that.
I think he looks optimistic, so I'm thinking he could
when
fix.
you talk about that horizontal autoscaling, so with Swarm, can we do the vertical autoscaling?
Can we what?
Vertical autoscaling?
Vertical autoscale? Yes, we can. No, we can't. I see. Because you have vertical autoscale for me is you have a big server.
On demand, you can create the nodes.
Okay. Can you create node with on demand?
So the vertical. So I think the Kubernetes we can do that autoscaling.
Okay.
So I don't know Swarm.
Yeah, in ways, yes, with Docker Swarm you can also do that, but it's not necessarily relying on the technology at the end, and that's not necessarily the way Docker will encourage you to do that. That's also why you did not really find a good example of this. But I think vertical scalability is easily reached than horizontal scalability, where your design is way more affecting your decisions, in my point of view. else with a question? There is a question? Yes, sorry, please.
So between you guys, it seems like that there are sort of conflicting things present. You said enterprise edition, you wrote for the enterprise edition, and you said the other one.
Oh, the fact is, I don't think it's necessarily a conflict. I think it's a little bit like I explained on the very first slide, is you don't necessarily go with the solution that you enjoy the most. Sometimes you have to make a decision based on on your situation, on the design that's available to you, on the investment you already made. So for me, I certainly recommend you looking into the Enterprise Edition. It's a very nice product. It's working very well. But again, it's not necessarily good for everyone or every situation. And in any ways, I would recommend going through the Community Edition first, and then figure out what's the added value to enable some of the Enterprise Edition features. And you can easily evaluate that using the 1 month license trial available online. It's very, very quickly done. And of course, every product used in the Enterprise Edition is available through Docker containers as well. So that's the beauty of it. Okay. And any other question? Okay. So Remy, give me the good news.
Yes, works. Everyone can hear me? Almost? Okay. So basically the problem was not related to Docker, it was related to IP, v6. Oh, I think it's way better like this. Here I know everyone can't read it, sorry. So if you can move on. So I just deploy the stack. And I do simple commands such as docker swarm init, and then my node become a manager, and I can join from other node using a docker join, simply as like that, with a token, of course, because security is everywhere and it's important also. It creates every services, and you can see there is some 1, 2, 3, 4, 5 services, and there is only 3 or 4 Docker containers. So maybe we can check on the other node what is this. So on the other node I do the join, if I can say, and now you can see there is some other container as well. You have some Redis, you have some Docker coins worker, so it's working. So now let's see how it's working, if I can, yes. So you can see there is some meaning hatches, and so you can see how fast I am, you know. So I think I won't want so much money with that speed, I think. If you are you guys doing some mining or no? Okay, but you should have something like a lot of zero more, 600 or 6,000 maybe per second to be good, to want some money. Okay, so let's start doing some fun. So as you say, if someone can hold me that, because I have to work in the same time. Complicated. Okay, so now I will just do here. Let's let's do the S3 views Docker Compose. So the Docker Compose is pretty simple, and you can see there is some instruction called deploy and replica. So you can put a number on it. Let's make 5. Okay, so now I updated the Docker. So I have to redeploy it, and then it will update it everything. See? So it takes a long time because I have a poor computer. So please, give me some money and I will buy a new one. I'm kidding. So definitely you should see. Is it working? No. But it's working here. It's really important. So you can see I push some replica to 5. So instead of 2, I have 5. And you can see I want some money. Oh no, not even close, but still you can see some good performance right now. So it might be interesting to do some Docker Swarm, and you can see the horizontal scaling a little bit. Okay, so you can view a lot of things here. So I will just I don't know all by heart, but for example, you can know. Sorry guys. Okay, so if I do docker node list, I can see my 2 nodes, and you can have a view on your cluster or on your Docker Swarm, which is cool, because sometimes you lost one node and you don't know that. So that is kind of a little bit boring. So you can also see what stack did you deploy. So here it's a simple DC Docker points with 5 services. So it's not that much complicated, but here it's an example, so it's kind of cool. So let's make some fun, guys. I will try to see if my computer can hold something. I will put the replica to 15, and we will see if that is working or not. I hope so, but maybe not. We will see if it will survive or not. Anyway, if it burns, I will have a new one, I hope. Okay, so normally it should increase a little bit the hashes, but something which is really important is that you can see some bottleneck. Sometimes scaling on the same computer won't work. You have to add a node and it will work, but still it's working fine. Okay, so one thing which is really interesting, and we already told you before, is that I will show you something, but it's maybe for Docker a little bit advanced, but still it's interesting. So I will just see if I do Docker PS. You can see there is some knob web UI, which we are waving here, okay? We are waving on the node 108. See? Is it available here? If I do Docker PS? No, it's not available here. So on the node 102, there is nothing. And if I can reach it, I don't know if that will work or not. We will see. If that is not working, then it's because it's not a manager, but I think it's working, right? So see, I can reach everything. I can reach the IP from the worker node because of the strategy. I will reach the 102 and he will say, no, I don't have, but I can route you to the 108, and so I can view the enginings of their web services on the wrong node, which is cool. And also a little bit afraid, but cool. Okay, so guys, I finished, but if you want to, okay. if you guys have some questions about Docker Swarm or want to try a lot of things about that, we can still edit the Docker Compose if you want. Maybe we can put 100, no, I'm kidding. Is there any question? Okay, so you want to say something? Your slide? Okay. It's on Gmail, right? Yes. Okay. So if I do Docker. Just wait. Yeah, it will be more simple because if it's too much work, I need to maybe to have some free. Okay. Sorry.
Okay, so I just wanted to get back on the mic for very briefly, and then after I think everyone can enjoy a good meal. But we wanted to say thank you for being there tonight. It's a very big crowd. We didn't expect so many people, so I guess that's proof that Docker is very exciting for many people. And we wanted to say to CMS as well, thanks for having us. It was very, very good being here. So again, feel free to come and see us and let's have a chat. Or in our presentation, you can also find our social media LinkedIn link so you can contact us as well. Thanks everyone, thank you.